morning, everyone. My goal today is to finish off 6.5, the average value of function, and to get started on the next section, which is a technique called integration by parts. Well, this is the guy that we've been using all yesterday, right? It's how you find the average value of a function. It's 1 over b minus a, the integral of f of x dx. And I think we've done quite a lot of practice at that, but I'm just going to do one more question just to get us warmed up. And then after that, we'll show you the other things that you get asked to do, which are to find a point between a and b where the function has the same value as the average. And then the last questions are puzzles and applications. So start off, just randomly stop somewhere. We did U-subs yesterday, didn't we? We did questions with U-subs. Nod your head in agreement, we did. Okay, so I don't need to do a U-sub. Did we do a sine 2x or cosine 2x, one where you'd use the linear shortcut method?
I think maybe like one.
One. Okay, let's finish on that. I'll make up my own.
Yeah, we did a 2 sine 8x one last time.
Okay, so let's do a 6 sine x plus a 4 cosine 2x. And we'll do the interval, in this case, from 0 to pi upon 2. And the question is the standard one, which is simply just find the average value of the function, right? I'm not going to do any more than just that for this question. So the average value of the function will be 1 over b minus a, the integral from a to b of the function. In this case, it's pi over 2 take away 0. The integral from 0 to pi upon 2. 6 sine x plus 4 cosine 2x dx. Okay, this little guy here ends up being 1 over pi upon 2. We're going to integrate those guys, which is sometimes called finding its antiderivative, and then plug in these two. Okay, 6 sine gets you negative 6 cosines. If you integrate a cosine, you get a sine, agreed? If you integrate a cosine of 2x, you get a sine of 2x. You also get what? What else?
1/2.
Right. With that 2, and that's where that 2 comes from. You happy about why it turned into 2? Okay. Now, 1 over pi upon 2 is really not good. Are you okay with 1 over a fraction being the same as its reciprocal? So 1 over pi over 2 is the same thing as 2 over pi. Now, this fellow is going to be negative 6 cosine of pi upon 2 plus 2 lots of the sine. Well, 2 of them gets you pi, so it's actually sine of pi. Take away negative 6 the cosine of 0 plus 2 times the sine of 0. Exact value. It's an easy one, I hope. What's the cosine of pi upon 2?
0.
Yeah. And so is the sine of pi. Cosine of 0 is 1, and the sine is 0. So after all of that, basically you get 0 take away negative 6, which is 6. And so the answer to what is the average value of this function is 12 over pi. We're quite comfortable with the process now. We've done maybe enough questions to get used to it. So that was just a warm-up really what we did yesterday. So let's move on to a different question where we are going hunting for the other two guys. So this one is similar to question 12. I get a lot of deja vu when I do these questions because I did this particular question, I believe, in my evening class yesterday. Oops, take that back. I will do that question, but that's a puzzle one. I want a guy that's the same value as one. I'll make one up then. Okay. Suppose you have a function 6x squared plus 4, and you're going to find its average value from 0 to 2. That is pretty standard. So that's going to be part A. Find the average value. So it's going to be 1 over 2 take away 0, then take it off from 0 to 2 of 6x squared plus 4 dx. It's going to be 1 over 2. Add 1, oops, don't need to do that. Add 1 to the power and divide by new power. Evaluate at 0 and 2. And what do you get? Well, you get 2 lots of 2 cubed plus 4 lots of 2. Take away all of the zeros. 2, 4, 8, 16. Add another 8. 24, half of 24 is 12. So the average value is 12. But part B is find the value C, right? Some x coordinate equal to C, such that the value of the function at C is the same number as the average value. So if you imagine what this might look like visually, can you imagine 6x squared plus 4 looks something like that, and 0 is here, so I don't care what that's doing, and let's say 2 is here, and we know that the average value is what, 12, so the average value is probably somewhere around about here, right? Can you see that there's at least one point on the curve where the function is going to have the same value as the average? So in this case, we're trying to solve when is f of c equal 12. Agreed? Now, the function is x squared plus 4, so basically 6c squared plus 4 equals 12. That's 6c squared equals 8. So c squared is 8 over 6, which is 4/3. So how do I find c then? I know what c squared is, it's 4/3, but how do I find c?
Yeah, take the square root.
Right. And normally when you do a square root, you do a plus and a minus. But in this case, won't we only do the positives because the x's can only go from 0 to 2. So that means the c can only be in the range 0 to 2. So it's going to be a positive, that fella, which is what, 2 over root 3? Or there's a much prettier version of it, is that? So what that is telling us, you see this guy here? He has an x coordinate of 2 root 3 over 3. Now you can do that same calculation by using Desmos. Now, Desmos won't quite be the same, but it'll be close enough. So I have a function, f of x, which I'm just going to call y equals 6x squared plus 4. Well, And I have a horizontal line, y equals 12. Now, where is y equals 12? Oh, it's up here. There we go. Now, we're only interested in values of x between 0 and 2. So essentially, we want that guy. See him there? And he is, if I can read the damn thing, 1.155. 1.155. Now, he's not an exact value, but he's the same thing as 2 root 3 divided by 3, right? So if you found out what that was as a decimal, you'd find out it was him. Now, in the question, I think that you get to do this too. The answers are decimals. So you could simply just plug it into Desmos and find out where one meets up with the other. Are we okay with that? Right, so if I give you a function and I ask you to get its average value, and then I say, I would like you to find at least one point, and we'll call that point C, that has the same value as the average value. So we want some value of this function, some x value, where you get 12 as the answer. And the answer is 1.155, or more precise, this fella. Any questions about that? Are we good? You don't really get a lot of examples of that, so there's my version. Next thing in the list then. Not quite sure what I'm sharing here. Let me go back out and in to make sure I'm sharing the right thing. I am. Good. Okay, so the next thing you're going to do, the next thing that we're going to do are going to be puzzles. So where's this puzzle hiding? Let's be down a bit. Here it is. This is a version of question 12. And it says, find the numbers b such that the average value of the function, that's this fella, is equal to 4, where the function is this fella, and it's on the interval 0 to b. So we are not being asked to find the average value. They told us it. We're not even being asked to find a place on this curve where it's equal to that. What we're being asked to do is to find some numbers for b, and according to them, there are going to be two answers. There's going to be a small value of b that works, and then there's going to be a larger one. So I guess we have to figure out how to solve this puzzle. Well, the only thing I really have to work with is that the average value, which is this guy. So that's what I'm starting. I'm just writing that down, and then I'm saying, okay, let's fill in what we know. I know the average value is 4, so I know this guy is 4. I know A is 0 and B is B. So what do I get? I get B take away 0 here. I get the integral from 0 to b, and I get a function that I do know, which is this guy. So that's kind of where we are right now. I've put in everything I do know. In fact, when you think about it, isn't the only thing I don't know, and that's b, which is what they're asking us to get. Right, that is 1 over b. Now, normally you would integrate and plug in the start and the finish. So I'm going to do that. 3 gets me 3x. 10x gets me 5x squared. Oops. And this guy gets me 3x cubed. And I have 1 over b. Plug in b, you get 3b. You get 5b squared. Take away 3b cubed. Minus, you plug in zeros, you get a whole load of zeros. So I now have that 4 is 1 over b times all this stuff. And remember what our goal is. We're trying to solve for b. Is there anything I can do to that right-hand side that might make my life a little bit easier?
You can divide out the b's and make it
Okay.
3 plus 5b minus 3b squared.
Would you agree that we are now looking at a quadratic equation? Now, if I wanted to make it a little bit more quadratic-like, and couldn't I subtract 4 from both sides? And get that. There are 2 approaches to this question. One I suggest you do, and the other I would suggest that you don't do. Actually, now to think about it, there's 3. How do you think I might solve that? Don't you worry if it happens to be one of the ones I would say don't do it that way. But how could I solve that if that was the question?
Factor?
I could try factoring it, yes. I'm 90% sure it can't factor, but it could. So that would be a very valid approach. Second approach.
Use the quadratic equation.
Yeah, now the horrible thing to me, the horrible thing about quadratic equation, isn't it ugly and it takes you forever and a day? Now, since these questions only want decimals, right? They don't want exact values. I can avoid that as well. So you might think, well, there's nothing left. There's one thing left, Desmos. If you want to solve this, can't you plug this into Desmos and find out where it crosses the x-axis? So I'm going to nip over here and show you how Desmos can be our friend for questions like this. Okay, now it's a minor thing, but you have to do it. I know the variables here are called x, but I don't want to call them that because that might annoy Desmos. Desmos, everything's an x or a y. So I'm going to type in the quadratic guy, which is y equals -1 plus 5b. Whoops, almost done it. 5x, take away 3b squared. And I just put in b after saying I don't want it. Yeah. That's the same thing as -1 plus 5b minus 3 squared. So if I hit enter, there's a little darling. I'll zoom in a little bit. Aren't we interested in when is it equal to 0? Remember? Okay. Well, if you go to that guy and you click on him, you get the answer 0.232. And if I go over here and I put my thing over it, can you see the other one is 1.434? So I'm going to go, the small one is 0.323. And the bigger one was 1.434. And we've solved the problem. Well, at least 3 decimal places. And if that's all they were wanting, there you go. Now, if they want 6 decimal places, or they want an exact value, which they don't, but if they did, wouldn't you have to use the quadratic formula or factor it, right? Now, if they want 6 decimal places, you probably have to use the quadratic formula, you know, but do all the calculations to at least 6. Do you like that puzzle? It's a little bit different, kind of not your usual question. Let's move on. Okay, I'm going to show you the applications. That's the last thing. Okay. Hopefully you're looking at question 13 right now. And they have a function that is capital T, the temperature, and it's measuring it 9 hours, what's this? After 9 AM is modeled by that function. So 9 AM is T equals 0, I'm assuming, and 9 PM is T equals 12. And here is your function. And they're asking you to find its average value. So it's going to be the integral, not from 9 till 9, because that wouldn't work, but from 0 to 12. Right. 0 is 9 AM, 12 is 9 PM. And this is the guy that you are going to have to integrate. Not very pretty, agreed? Now, the 46 is easy. Won't that just become 46T? How do you think you might want to take on the integral, the antiderivative of 19 sine pi t over 12? How do you think you might want to tackle that? Because that is pretty ugly.
Finding u.
Yeah, a u sub and pi t over 12 would probably be the safest. Technically speaking, it is a linear shortcut method, but I'm not sure there's a lot going on there. You might not do it quite correct. Now, question 14 is a tutorial question, very like this fella. In fact, almost identical. But this guy takes you through the whole process. So if you do 14 first, 13 will be a lot easier. Now, question 15 talks about a function called the linear density function, which is basically just a formula, a function, that tells you how dense a rod is in this case at position X. So in this story, which is what I'm going to be doing in a few seconds, question 15, the density function rho is given by 16 over the square root of x add 4. And the rod is 5 meters long, so that tells me x starts at 0, and at the end of the rod it's 5. So let me go and show you the setup for this one. I won't finish it, but I will set it up. All right, so you got a rod, its density, right? So maybe at the beginning of the rod, it's, its density is 4 kilograms a meter, and then at the end it's 20 kilograms per meter. If you want to find the average density, oh, by the way, that is the Greek letter rho, R-H-O, which you will pronounce as if it was the word roll. So, unless Americans pronounce that differently, in which case I'm ignoring you, it's roll. Not ra'awa, or God, who knows how you could say it. Right, back to our problem then. You want to find the average density. Well, won't it be? Can you see all I've really done is turn the F into a rho? Right? So in this case, it's going to be 5 take away 0. The integral from 0 to 5, 16 over the square root of x add 4 dx. I'm going to help just a little bit more. What strategy can we use to integrate 16 over the square root of x add 4? What method?
Use substitution?
Yes, the one I would go. So the U is just going to be that guy. Not the ugliest substitution in the world. If you differentiate with respect to X, you just get 1. And when you do the crossover, you can pretty much stop. So the average density is 1/5. The integral, oops, we don't need the integral quite yet. 16 over the square root of U times du. Okay, where would I go next? What would I do next?
Make it 16u to the negative 1/2.
Yeah, in fact, can I pull the 16 outside?
Yeah, you could do that too.
Not that it would be wrong, not if you didn't, but just get the damn thing out of the road. Right, at this point in time, wouldn't you be able to do power rule, convert back to the x's, plug in the start number of 0 and the finish number of 5, and who knows, 5 minutes later you get the answer, and that's you finished. Are we good with that? So it is a kind of application. It's application using using density function to do it. Okay, last chance for this section for a while. Any questions about what we've covered before we move on to the next section? Are we good? Right. We're about to start a new chapter. It's kind of a cool thing. When you start chapter 7. In particular, 7.1. And this is a technique called integration by parts. U-sub is a technique, right? U-subs allow you to find integrals that wouldn't be doable any other way. But there are some circumstances where U-subs don't work. And a technique, this particular technique was discovered to help us find the antiderivative, right? The integral of other situations. What is it like? The closest it is to, what's it like? Closest thing it is in Calc 1, remember the product rule, which was a technique that allowed us to find the derivative of a function if you thought of it as being an f of x times a g of x, right? That kind of thing. This is kind of the integration version of that. What it allows us to do is it allows us to find the integral where the thing you want to integrate is really made up of 2 things multiplied together. Like x sine x would be an example of that, right? X cubed e to the 2x. X tan x, right? Things like that, right? That would be an example of a situation where you could use integration by parts, where the function isn't just one thing, but quite clearly 2 distinct things multiplied together. And it's a formula. Now, not the kind of formula you normally are used to. It's f of x, capital G of x, take away the integral of f dashed x, capital G of x, dx, where f dashed of x is the derivative of, which is kind of obvious, but I'm telling you anyway, right? And what do you think capital G of x is?
The antiderivative of g of x.
You're right. Okay, so how do you use this? Well, in normal Calc 1, you've got an f, you've got a g, you've got an f dash, you have a g dash, you plug them all in, you tidy it up, and you're finished. This formula contains an integral in it. You see over here? Formulas shouldn't have integrals in them, right? That's not what formula should look like, but this one does. And because of that, don't think of this as just a formula that you plug and chug, although a lot of it is. It's a little bit more than that as well. It's a process, because you have to do stuff to get to the answer. And it's not just, I plug things in and the answer's in front of me. I don't really need to worry about it, which is kind of what Calc 1 would be like. Now, this you have to put some effort into, and you have to do more work than you perhaps think you need to. So I'm going to choose a very simple, I think, a very simple example. Let's find the integral of this guy. And I'm going to do the indefinite integral, so we don't need to worry about numbers right now, which means that when I'm finished, I better remember my plus c. Okay, in this question here, step 1. Choose the f of x and the g of x. Now you might think, why is that even written down? Is he just being, pedantic? No, it's actually more important than you think. In quite a lot of integration by parts questions, the order isn't the first guy is f and the second guy is g, which is what you would expect it to be. The vast majority of them, that is true, but there are situations where that is not the order that works. So you do need to think about it a little bit, but there are rules. Typically, f of x will be anything that's got a power of x in it. So if it's x squared sine x, 3x e to the x, 5x cubed tan x, that kind of thing. The x squared, the 5x cubed, that guy is very, very often your f of x. And whoever the other bit is your g of x. So in this case, f of x is 3 and g of x is e to the x. Right, what you would expect. Now, what I tend to do here is I then find the derivative, and while I'm at it, the antiderivative. Now, the antiderivative of e to the x is my favorite antiderivative in the world because it's one of the few that I don't screw up. The antiderivative of e to the x is
E to the
E
x.
to the x.
e to the x. Can you see why it's kind of hard to screw that one up? Right. So there's step 1. Identify who the f's and g's are. Right, step 2 now. Use the formula. So here goes. The integral of f of x, g of x, dx is going to be f of x, capital G, take away the integral of f dashed x, capital G, dx. So in this particular case, question, it's going to be that guy. Now, f of x is 3x. The antiderivative, capital G of x, is that guy. Take away the integral. F dashed of x is 3. Capital G of x is e to the x, dx. So this integral, right, this guy's antiderivative is this guy, take away that. Now in this particular question, can't we find the answer to this integral? What's the integral of 3 e to the x?
3e to the x.
So take away 3e to the x plus c. Technically, there's a step 3 here, but we didn't really need it. And step 3 is repeat process until finished. Well, in this case, I didn't need to repeat the process, right? I was pretty much finished. So far, so good. So the integral of this guy is that. Now, I'm not going to do it, but if you wanted to, you could prove it. Differentiate that the usual calc one way. I bet you ends up being this guy. Well, oh, back to this question for a minute. The only way to do this is by integration by parts. If some of you were thinking, I could do a U sub and get the same answer, you'd be wrong. Just think about it for a moment. What possible U sub could you use here? Well, could I use 3x? Well, you could, but it wouldn't help. Could I use x? No, because you never use x. If you do a U sub of x, don't you just get 3u e to the u? You don't get anything. However, if I wanted to integrate this function, what method would I use?
U substitution.
U sub. Do you see that what an extra power can make? What a difference an extra power can make to the method. If I tried to do this one with integration by parts, I'd be in trouble. If I tried to do this one with U subs, I would be in trouble. So can you see that they all have their own little niche market? U subs deals with these kind of things, integration parts deal with these kind of things, and they don't really interlock much. There's probably a couple of questions out there. If I thought hard enough, I could probably make one up where you could do both methods, right? You could do it by U subs or you could do it by integration by parts, right? Both methods would work. But in the vast, vast majority of situations, U subs are for U subs, integration by parts are for totally different kinds of questions, and only one of those methods will typically work. Well, I've got my little hit list. I'm going to show you a little bit more difficult version. I would like to know the integral of this guy. Okay. Based on what I've said earlier, I would assume here that the choices are pretty straightforward, right? This one is not meant to be a trick question. Would you agree that the x squared and the sine x is the most natural way to split this thing up, right? X squared is the first guy, sine x is the second guy. Now, while I'm at it then, the derivative here is 2x and the antiderivative here is negative cosine x. Right, when you integrate a sine, you get a negative cosine. So that's step one done. Now step two would be to use this formula. F of x is this guy. The antiderivative is negative cosine x. Take away the integral. F dashed is this guy. antiderivative is this one. And that times that gets me negative x cosine x. That's a negative, so is this. They combine and you get plus 2x cosine x dx. Do you see that this integral needs work done to it? Right? I don't know exactly what the integral of 2x cosine x is. Don't I essentially have to do integration again by parts? So my step 3, repeat the process, is now going to kick in. So it's going to be equal to this fella plus whatever that is. Right? Now it gets really messy if I start writing the working for that. So I'm going to do it over here like a little side job. Right? We need to find out what this is. Whatever it is, I'll write it down here and we'll be finished. Okay. In this question, who is the new f and the new g? In this integral, who's going to be the new f and the new g? Oops, don't need that. I don't hear lots of answers.
F of x would be 2x, right?
Hmm?
And then
Yeah.
g of x would be cosine x.
90+% of the time, the first guy, the x's, is going to be your f. We won't see situations where that's not true today. We might see later on tomorrow situations where you have to be a little bit more careful. Now you might think, well, that's going to be hard. It's not as hard as it seems. Typically, you only have two things, right? So one of them has to be f and the other has to be g. If you pick the wrong one, you'll find out after a couple of minutes that this is going nowhere, right? This answer makes no sense. I don't know what to do. That's probably an indication you picked the wrong one. So you just throw that piece of paper away and you go back to the question and you switch places. So it's not the end of the world, right? If you get caught out by picking the wrong f and g, right? You will eventually, because there's only two choices, pick the right one. Now, in this case here, the derivative is 2 and its antiderivative is positive sine x. So we have f of x sine x, take away f dashed of x sine x, and I have 2x sine x. Antiderivative of 2 sine x, isn't that negative 2 cosine x's? Right, antiderivative of 2 sine x is negative 2 cosine x's. Bring that negative into play and you now have positive 2 cosine x's. And go over here and you write 2x sine x plus 2 cosine x's plus a c, and the question's over.